Hi champs, welcome back, and in this video we will discuss some of the basic concepts of what chemical equations and reactions are all about. So we'll take the same example what we discussed in the earlier video, magnesium plus oxygen giving magnesium oxide. In a word format, the reaction could be written as magnesium plus oxygen giving magnesium oxide. Now whatever is there in the left hand side is or the reactants, and whatever is in the right hand side is or the products. Okay, so you have one product or you can have multiple products for any reaction. Now this is what reactants and products are all about, but we need to express this equation this in the form of symbols, for the elements. So there we go. Unless you express that as the symbolic format, that is not the accepted way to express a reaction, you know that. So a chemical equation represents a chemical reaction. So what is a chemical equation? A chemical equation is nothing but the actual chemical reaction, and it gives the complete picture of the conditions and the state of matter of the elements that take place in that particular reaction. So in the coming videos we are going to discuss about all this. In this video, let us just have the basic concept. Mg plus O2 gives MgO. Good. Now this is the symbolic representation. You have already studied that in your earlier standards, and here comes a fun-filled activity. There's nothing funny about it, but then it's interesting because what you find here is that magnesium plus oxygen gives MgO. In the reactant side you find one magnesium, the count of magnesium is 1. In the product side also the count of magnesium is 1, but in the reactant side the count of oxygen is 2. But in the product side, the count of oxygen is just 1. Now, you cannot leave it like this. You need to go ahead and get it balanced across the reactant side and the product side. Whatever is present in the reactant side must be equal to whatever products are formed in the product side. So the left hand side and the right hand side must always be equal with respect to each and every element that takes part in that reaction. Okay, so let's go ahead and see what we do. There's no need for you to go ahead and put a tabulation column here, just like what is given in the slide, because that is given for your understanding. When you put a tabulation column like this, you find the symbol, you find the number of elements in the reactant side, you find the number of elements in the product side, and oxygen is given in red only to denote that there is an imbalance, it's not equal. So what happens is, in the reactant side oxygen is 2, while in the product side oxygen is just about 1, right? So we need to go ahead and balance that. Let's go ahead and do that. Add 2 to MgO in the product side. Now when you do that, what happens is when you add 2 to the MgO in the product side, oxygen is balanced. Now we find 2 oxygen in the reactant side and in the product side also, but there is a problem with the magnesium itself, because magnesium now is 2 in the product side but 1 in the reactant side. So all you need to do is add a 2 to magnesium in the reactant side. Now you have 2 magnesium, 2 oxygen in the reactant, and 2 magnesium and 2 oxygen in the product side. Now it's equal. So it's as simple as that. Okay, so now you may ask me how to go ahead and balance the equation. I'll give you some simple tips. Try to find out which element has the highest difference in the numbers. So usually you find it with either oxygen or hydrogen, or sometimes some other elements also, depending upon the reaction. So try to balance that which has the highest difference from the reactant and the product side. It's a good practice to start like that, but all you need to do is apply your logic. If you write it, if you practice it, then you'll be more comfortable in getting the equation balanced. So we'll see one example, at least one example, on how to go ahead and get an equation balanced. So that is all in this video. We will meet in the next video. Thank you.